Hi folks, Mr. Long here. I'm going to do a screencast today on differentiating negative exponents. I want to take you back just to our basic rule for differentiating polynomial functions, or what we call power functions. So if we have an original function, a times x to the n, then the derivative or the slope function, y prime or f prime at x, is I bring the n down to the front and multiply by n, which you see right here, and then it's times x, and then I reduce the exponent by 1. So as an example, I'll do this one here. I bring the 2 to the front, so y prime is 2. I leave the original 3, which was a, and then I have x, and I reduce the exponent by 1, 2 minus 1. So y prime will equal 6x to the 1, which I don't have to write the 1, so it's just 6x. Okay, that's just a quick review. So those are positive exponents. What I'm going to do is go through some examples now with negative exponents. What I want you to remember is that at any time you can pause this screencast, rewind it. You may have to watch it a couple of times. I would encourage you to write down the examples that I'm doing in your notes, right? So you have a set of notes. And that's definitely going to help you. Okay, so I encourage you to do that. So let's start by reviewing some exponent rules. So here we are. Let's review our exponent rules. So this first question says, represent this with a positive exponent, 3x to the minus 4. Minus 4, what does that mean, x to the minus 4? Well, positive exponents mean repeated multiplication. Therefore, negative exponents mean repeated division. So what it really means is 3 divided by x 4 times. 3 divided by x 4 times, because there's a negative 4. 3 divided by x 4 times. So what we would have is 3 over x to the 4th. Okay, that's what that equals. So I'm writing a negative exponent as a positive exponent. By the way, if it just said x to the negative 3, that would mean there's a 1 out front there, right, that you don't see. That means 1 divided by x 3 times. Okay. All right, let's look at the second one. It says represent this one with a negative exponent. So what this means is, I've got it right here, it says 4 divided by x to the 6th. If I want to have that as a negative exponent, I bring the 6 up to the top and make it negative. So it's 4x to the negative 6, which means the same thing. 4 divided by x 6 times. Okay? Positive exponents, repeated multiplication. Negative exponents, repeated division. Okay, so now, what happens if we have to take a derivative of functions like this? Well, first step is we take the exponents in the denominator and rewrite them as negative exponents. Then what we do is we apply the power rule for differentiating, no different than we did before. It's just the regular rule. And then the third thing, we represent any negative exponents in our differentiated answer as positive exponents in the denominator. So we go back to it the way we started it. So let's go through this example right here. 5 over x minus 3 over x to the 4th. Well, first thing we want to do, step 1 right here, is to write it with negative exponents. Well, the exponent on the bottom on that x is a 1. So I can rewrite that as 5x to the negative 1 minus 3x to the negative 4, right? Because, again, repeated division is shown as negative exponents. That's what y is. I'm not as concerned with y is, well, I am concerned with it, but now I have to figure out what the derivative or slope function is, y prime. So, again, I bring the negative, now I'm multiplying by the exponent, so that negative 1 will come to the front, so it's negative 1 multiplied by 5, x now to the exponent of negative 1 minus 1, negative 2. I reduce the exponent by 1. 1 lower than negative 1 is negative 2. Okay, that's a little counterintuitive sometimes. All right, let's do the next one for this one here. So it's going to be minus, and then I bring that negative 4 to the front, 3, and then it's going to be x to the, reducing the exponent by 1. 1 lower than negative 4 is negative 5. Okay, so now what we want to do is simplify. So that's going to be negative 5x to the negative 2. And if I look at this one, I've got a negative there and a negative there. Two negatives multiplied together makes a positive. Plus 12x to the negative 5. And finally, the third step is I rewrite with positive exponents. Y prime equals, so let me move that up a bit, negative 5 divided by x squared, because I'm dividing by x twice, plus 12 divided by x to the 5th. And that's it. We're done. Okay, so I've rewritten it with positive exponents in the bottom. Sometimes you're going to see answers in this form in the backs of books or in solution sets. Sometimes you're going to see it in this form. The best form is changing things back to positive exponents. Okay, so if you can see the pattern here, what did we do to do these? First thing I did is I changed all the positive exponents to negative exponents by bringing them up to the top. The second thing I did is applied my what's called the power rule of derivatives, where I take the exponent and bring it to the front and then multiply that by the coefficient, reduce the exponent power by 1 from negative 1 to negative 2. Okay, see that process. Again, you may want to look these over. You should make yourself a set of notes from these. Let's move on. Okay, and this is some new notation for you. When it says d by dx right here, that means that we haven't differentiated yet, but we need to. So if it says d by dx, it means we haven't differentiated yet, but we need to. So, and whatever's in the bracket is what I have to differentiate. Again, I'm going to repeat. D by dx means I have to differentiate or get the slope function, but I haven't yet. So here we go. So for this one, I can do this one fairly directly. 4 times 3 is 12. X, and then I reduce the exponent by 1. 4 minus 1 is 3. Okay, so that's the answer. So this means the left side here means I haven't differentiated, but I need to. Over here is my answer. It's I actually did differentiate. So this is the derivative. This is the thing I have to differentiate. Okay, that notation is very important. So I should have gone back here. Something I want to point out here is when it says d by dx, 3x to the 4th, there's one simplification I can do beforehand. This 3 in mathematics is known as a coefficient. It's multiplying by x to the 4th. I can remove that 3 from that set of brackets, right? Because I know that that equals d by dx of 3 multiplied by x to the 4th. Well, that 3 is just a coefficient that's going to multiply in. So I can bring it out to the front and I can say, it's called a constant multiple rule, but that means I've got 3 derivatives of x to the 4th. It's the same thing, right? Whether I have the derivative of 3x to the 4th or 3 derivatives of x to the 4th, it's going to get the same result. Because if you look, that's 3, and then once I do the derivative of this, which is 4x cubed, if I multiply that together, I still get 12x cubed. It's the same thing. Okay, very important. And that's called a constant multiple. So again, you get the same result. Whether you bring the 3, whether you differentiate it like we did here, where we left the 3 inside and differentiated, did 4 times 3, or, so you can differentiate with the 3, or you can differentiate afterwards and then multiply by 3. Okay? It's called the constant multiple rule. All it means is the derivative of 3x to the 4th is the same thing as 3 derivatives of x to the 4th. Okay? That's really critical. Okay, let's move on to another question. Okay, just one second. I want to go back for a second. Okay, here we go. Let's do this one. So I almost did things out of order there. Here's where that constant multiple rule is actually pretty important. So I know that I can rewrite this as d by dx of 1/4 of 1 over x, right? That's multiplying that out. 1 over 4 times x is the same thing as 1/4 of 1 over x. I can use what we call that constant multiple rule, and I could do the derivative of 1 over 4x. I could do that derivative, or I can do the derivative of 1/4 of 1 over x. And that's probably, this way is a much easier way to do it. So what I want to do here is then write that as 1/4 of the derivative d by dx of 1 over x, which is 1/4 d by dx of x to the minus 1. Right? I always bring that up to the top. And now I can do the derivative. So it's 1/4 of this derivative. Well, we know what that derivative is. I take that minus 1 and I bring it to the front. So the minus 1 comes to the front, and then it becomes x to the minus 2. I reduce the exponent by 1. So when I go to simplify that, I've got 1, that's negative 1 over 1, and I multiply the numerators with the fraction. 1 times negative 1 is negative 1, and then it's over 4x squared. Okay, so I can write that, or I can apply the negative to the top, the bottom, but just not both. I guess the best answer, the best format would be negative 1 over 4x squared. Okay, with my negative out front like so. Okay, that would be the best answer. Those ones are tricky ones, right? It's hard to know what to do with those. But again, I would look that one over again. All right, so that's our section on negative exponents, or variables in the denominator, and how you get the derivatives.